Okay, so welcome everybody. Welcome to Cloud Native Portland meetup, online meetup right now. Our speaker today is Ethan Jackson from Kelda, right?
Kelda. Yeah,
Yes,
Kelda.
from
Yeah.
Kelda, who is an expert in Docker Compose and is going to explain how you can mess up your Docker Compose. Um, and he has said he's happy to take questions throughout the presentation. So if you have a question during the presentation, then please either post it or say, I have a question in chat, and then I can read your question or you can ask your question out loud, either way. With that, Ethan, you want to go ahead and start up?
Yeah, thanks. Let me share my screen. Okay. Cool. So thanks for inviting me to speak. Quickly to introduce myself, I'm Ethan Jackson. I'm one of the co-founders of Kelda. My background's in software engineering. I did a lot of low-level networking stuff, particularly on an open source project called Open vSwitch back when OpenStack was popular back in the day. And Kelda is a company that's focusing on fixing the development experience for containerized products. Our basic idea is that containers made everything vastly more complicated than it needs to be for developers, not for SREs. And our goal is to fix it. The first service that we've built for this is something called Blimp, which is a cloud development environment that is really easily onboarded from Docker Compose, which is where this talk came from. In the process of doing the research for Blimp, we had a bunch of people kindly share their Docker Compose files with us, and we noticed some common mistakes that really make the development experience for Docker Compose really inefficient for people. So I'm not sure if I'm an expert in Docker Compose, but I just noticed these sort of common patterns that if people fix, they can make their experience developing while using Docker Compose a lot better. So I collected them in this talk, and here we are today. Okay, so just to make sure that we're all on the same page, Docker Compose can be used for a lot of things. It can be used for production. There was a while before, this is a CNCF meetup, so a lot of people know here, I'm sure, that Kubernetes kind of won the production container orchestrator war. So some people still use Docker Compose in production, but that's not really what I'm talking about in this talk. What I'm really focused on is Docker Compose used by a developer on their laptop while building containers. So the typical setup, you've got a developer working at perhaps a company that's building a containerized app. They've got some code that they're actively developing and a bunch of microservices or just services that are containers that their code depends on. And the pattern I've noticed, and it'll be interesting to me if people agree with this, but I've seen that even when people are using Kubernetes in production, a lot of developers use Docker Compose to manage their test dependencies locally. And I think the reason for this is Kubernetes is so complicated, appropriately so, because it's trying to manage a self-healing, scalable, distributed system in production. But for the typical developer, particularly developers without DevOps experience, the concepts behind Docker Compose are a little bit more easy to understand. So the pattern we see is that even when people are using Kubernetes in production, they're using Docker Compose locally. And the last point I want to make is that speed is really, really critical in this setup. If you're here, you're probably a programmer, so you know that every kind of minute spent delaying, waiting for containers to build, fighting your development environment in general is a minute you're not spending programming, and it's an opportunity to lose focus. So it's really important to have a fast, streamlined setup for testing this stuff. Okay, so that's kind of where we're talking about. The first mistake that I see is the most basic. So if this seems kind of obvious, bear with me. It'll get more complex and interesting as we go along. I do spend some time on it because despite this being a little bit basic, I see it done all the time among some of our users. And it's one of the easiest ways to get a big benefit in your development workflow. So I do spend some time on it. The mistake is frequent container rebuilds. So back when we were working, on monoliths before containers, obviously it was a mess in production, but the development experience for the developer was actually pretty simple. You wrote your code. If it was a compiled language, you built it and you ran it on your laptop and it ran. Nowadays, you write your code, you build it on your laptop, and then there's this additional Docker build step to create a container. Then you run the container, and that's how you test your code. And the problem is that Docker build step can take a really long time, depending on how you set up your container. If you're lucky, it only takes 2 or 3 minutes. If you're unlucky, it can take 10 or 20 minutes. And furthermore, this is kind of exacerbated by the fact that a lot of Docker files are bad for development. So they're taken from the production container Docker file, and they're optimized for a really good production experience, which usually means a small image size, but they aren't optimized for really, really fast builds, which is what you want in development. Okay, so what do we do about this? There's kind of 3 approaches. You can develop outside of containers, you can optimize your Docker file, and you can use host volumes. There's someone who needs to mute themselves. But anyway, thank you. So I'll talk about all 3 of these really quickly, and then we'll move on to other stuff. Oops. Okay. So developing outside of containers. So the easiest solution to slow Docker container builds is to simply not use Docker while developing your code. Obviously, you're still going to have a CI/CD process that builds and tests your container. But while you're doing the kind of core code test debug loop, you can run all of your dependencies, all of the containers that your code depends on in Docker Kompose on your laptop. But then the code you're actually working on, you can just run on your laptop outside of container and access your dependencies over localhost. Again, this is like fairly straightforward thing, but a lot of people I see don't do it. If it works, it's the easiest thing to do. It often doesn't work because the code you're working on has some particular dependency on the particular environment that the container, the code that you're working on might actually depend on libraries or things that are actually in the container that it needs to run. That's typically not the case with something like Node.js or Python, but you do see it sometimes. So anyway, this is what I recommend if it's possible. The second approach, and this is where it gets a little bit more interesting, is maintaining a separately optimized Docker file specifically for development. And I mentioned this earlier, the optimal Docker file for production is not the optimal Docker file for development. So, oops, I forgot to change the title on all these slides. That's okay though. So you'll very frequently see something like this in people's Docker files. For people who are like really up with the latest stuff that Docker's been doing, this style of building a Docker file isn't super necessary anymore. But in the early days of Docker in particular, and still to some degree, in order to reduce the size of your Docker image, instead of breaking the Docker build up into multiple steps, you'll compress them into one big step. And often you'll see people do things like do an apt-get update to install a bunch of dependencies, or to update the registry of dependencies, install something, and then delete everything just to make sure that the final image is as small as possible. And again, this makes a lot of sense in production. The problem is that in development, you end up with these Docker files where if you make even little tiny changes, you have to rebuild the entire Docker file. And that is really slow. So as a comparison, this is our Docker file that we use to build Blimp for development. And you'll notice that we really went out of our way to break every little thing we do down into the tiniest individual steps possible. As a result, the image is larger than it would be otherwise, and the build starting from zero probably takes a little bit longer than it would otherwise. But when code changes in a frequently changing part of the code base, this Docker file results in much more incremental rebuilds if you need to rebuild. And as a result is a lot faster for development on average than the kind of highly optimized, highly compressed Docker file. So the basic thing we tend to recommend is to have a dedicated Docker file just for development that you have in sort of many small steps, and you put the frequently changing stuff later in the Docker file. As a brief aside, you can actually get the best of both worlds by using multi-stage builds, and we actually did that in this Docker file. We had their kind of highly layered instructions at the beginning of the Docker file, and at the end, we use multi-stage builds to copy out the build artifacts into a really kind of minimal small Docker file, which we use, or into a really minimal small image that we use for production. So if you can do that, great. Often the people who maintain the production Docker file will be different than the people maintaining the development Docker file. So something like this isn't possible, but if it works for you, great. Okay. The last thing that's pretty commonly done, but again, not everyone knows about, is avoiding the container build altogether by using a host volume to mirror your code directly into the container. So the idea here is you build a container that has everything that your code needs to run, but instead of putting the code itself into that container, you use a volume to mount a directory that's in your laptop into the appropriate location of the container. You edit your code locally on your laptop. And then as you sort of change your code on your laptop, it kind of automatically gets synced into the container, and you use something like nodemon to watch that directory for changes and restart the process inside the container. So when you make a code change, the container doesn't restart, but the like Node.js process that's running inside of it does. You would never do this in production, obviously, for obvious reasons, but in development, it can work pretty well. You can end up in a situation where, you know, the time between I change my code to I can see the results of changing the code is, you know, less than a second, because we don't have to rebuild anything. Typically not done for compiled languages, but really common in Node.js, Python, things like that. Okay. Let me pause. Any questions so far? I'm going kind of fast. I'm just checking the chat. I assume I'll get interrupted if there's questions. So if not, I'll go
I haven't
on.
seen anything in the chat. Does anybody have any questions about not rebuilding containers?
No, okay.
Okay.
Cool. All right. So that's kind of the table stakes stuff. Actually, at a CNCF meetup, I would expect a lot of the people here to know this. Now getting into the like less commonly known things. So one that bites a lot of people that actually has a pretty easy fix is dealing with slow host volume. So this is assuming that you're following the approach I've said earlier, where you're mounting code into the container and developing that code locally. Host volumes in Docker are pretty slow. The issue is on Linux, they have native performance. It's just a directory that's mounted in multiple locations, and that, you know, performs well. On Windows and Mac, Docker runs inside of a virtual machine, a Linux virtual machine. That's how they get it to work. And volumes are implemented with something that looks a lot like a network file system. And it's called OSXFS on Mac. I can't remember what it's called on Windows. The issue with this network file system is it can be really, really painfully slow, particularly when you have large numbers of small files that you're kind of dealing with in the file system. And that actually occurs all of the time when you're writing interpreted languages, because like in Node.js, for example, they have the node modules directory in which you download all of the dependencies of the code that you're working on. And you're going to have 30, 40, 50,000 tiny little JavaScript files that, string reverse or whatever they do. And just kind of downloading those and getting them onto the file system with this kind of inefficient network file system can be really, really slow. The reason it's slow is OSXFS follows, it's a POSIX file system, so it follows the strong consistency guarantees that such a file system requires. So basically, if you have multiple writers and multiple readers, at all times, all writers and readers will agree on the contents of any particular file. It turns out in development, you don't really need that. You typically only have one writer, which is you editing your code. You're not, running a crazy multiple database setup on your laptop usually. So you only have one writer, that's you, and then you'll have, two readers, your file editor and the container. But since you only have one writer, the consistency guarantees aren't particularly important. So what I recommend here that I don't see people do often, but they should, is when you're working with host volumes for mounting your code inside of a container, you just turn on cached mode. And what this does is it signals to Docker that your laptop's version of the code is authoritative. So in the unlikely event that both your laptop and the container write to the same file concurrently, your laptop's going to win that race. So it's not strongly consistent. You can lose data if you have multiple writers. But by relaxing that consistency guarantee, it's vastly faster, and there's no real cost in the sort of normal workflow. You wouldn't run a database this way, but for code, it's totally fine. So that can really cause a significant improvement in the speed. There's also some people will use things like rsync or unison or mutagen or syncing. There's a bunch of other techniques you can do to just avoid using volumes altogether. And they're kind of a pain. So in my experience, they often aren't worth it. They kind of came along before this cached mode thing did, but in modern development, they aren't necessarily necessary. But if you're using them, it's fine. Okay. Oh, okay. The next thing you can do, again, the issue with consistency and in general with file systems is just dealing with these large numbers of small files. Usually when you have large numbers of small files, particularly in interpreted languages, that's going to be in your package management directory. So a really simple thing you can do is just not mount your packages. So in this example, this is a Node.js example. You've got a container that's doing Node.js and it uses node modules for its dependencies. And what we've done here is we mounted our code into the container, and then we did an additional volume creation that's a subdirectory of the host volume mount. And what this does is it overrides the user source app node modules path and says, okay, make that, don't have that be part of the host volume. Instead, create a sort of standard Docker volume that lives entirely within the Linux virtual machine for this node modules directory. And as a result, that node modules directory, things in that directory, don't get synced over from your laptop and don't have the performance issues that slow host volume typically do. This can be kind of a pain. Like, to set it up, you have to obviously somehow install the node module stuff. And you can do this with npm install, like in the entry point of the Docker file. You end up with some like pretty ugly Docker files, which of course you wouldn't use in production, but for development, it's fine and it's fast and it's efficient and it works fine. Yeah. Okay. That's number 2. I'll just pause for like 5 seconds in case there's questions, but sounds like not. So, okay.
Yeah. Any questions, folks? So actually here, I'm going to interrupt with this. I'm going to ask you a question, which is,
Yep.
how many people on this call have written Docker Compose files before? You can either speak up in chat, speak up out loud. Okay.
Just very
Brooks is him.
as a in tutorials and learning a few times,
Okay.
and maybe for a few personal projects.
Okay.
How many
Johnson's
used Docker Compose? I found a lot of people don't write them, but they just have one sitting around that someone else in their project wrote and got committed or something.
Yeah. John and Martin said they've both written a bunch of them.
Yeah.
So yes, how many people are using files written by somebody else? For that matter, how many people are using files written by somebody else that already has one of the 2 problems that Ethan went over?
So Docker files or Docker Compose files?
Docker Compose files.
Yes, I use them written by someone else as a developer. Like, for example, there's one Bookstack. There's an application, and there's a Docker Compose Solid Nerd has on GitHub. And if I want to run Bookstack, the easiest thing for me to do is go through this process. And then I use it on my local machine. So it's kind of an unorthodox way. I don't think people usually use Docker that way, but I end up doing it a lot.
I don't know how unorthodox it is. I mean,
Good.
The kind of right thing to do is Kubernetes, but if you're an individual with a small project, it's often not worth it. So people running just 3 or 4 containers with one person, I see Docker Compose all the time.
Yeah. I know the Podman project has been working on something to serve the same purpose.
It's not ready for.
It's not ready. Nope.
It does do a good job of generating a Kubernetes type, whatever the Kubernetes version of the Docker Compose file is.
Yeah, and for Podman, they used to actually have it pushed to Minishift, but Minishift is not a thing anymore. So they're trying to figure out what they want to do next.
It's kind of a brief aside. Of probably the 100 or so companies I've run into that are doing Kubernetes in production, like Minikube and Minishift usage, in my experience, is really small. Outside of people who are actively doing Kubernetes development, mostly because most developers of these companies aren't Kubernetes experts. You're going to have, 5, 10 SREs who are. I'm actually kind of curious if if I'm just getting kind of a skewed sample, or if that jives with other people.
I was going to say my guess is if there were tons of Minishift users, the OpenShift project would not have dropped Minishift.
Yeah, not have killed it. Yeah.
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 Although that being said, K3S, which serves the same purpose for a bunch of people, has become a very popular project.
Yeah. Do you think it's kind of supplanting Minikube a little bit?
I'm not sure. I kind of get that feeling, but I have no statistics at all.
Yeah, sure. Yeah.
I mean, the direction that the core Kubernetes project is moving in is actually replacing Minikube with Kind.
Yeah.
Kind is short for Kubernetes in Docker, inside Docker.
Yeah. Yeah.
Speaking of which, that's what I should get a presentation on for Cloud Native PDX. Maybe I'll do
Yeah,
one.
that'd be great. Yeah, I don't know anything
Okay.
about that project, so that'd be great.
Okay, so want to go on with ways to mess up number 3?
Cool. All right. So this one, Kruft Messiness. The basic idea, if you look at a lot of these things, they're just a mess usually. A lot of unnecessary configuration, network config, unnecessary volume mounts. Like people's Docker Compose files in general just look like they've been copy and pasted from something that was copy and pasted from something that was copy and pasted. I'll see a lot of people like weirdly specifically specify IP addresses for all of their containers. Like it really, really, really matters that my container's IP is 192.0.168.3 or something. And you just end up with something that's really, really hard to maintain. My opinion on how to deal with this, I wrote a blog post on it actually last week that was shockingly controversial. I was really surprised. So, you know, if you don't agree, don't get too mad. But my general opinion is that, like, the pattern I see is people are like, okay, like containers are great, Kubernetes are great. Like they hire a bunch of SREs. Those SREs like figure out production and they figure out CI/CD and they get that all working really well. And the development environment is a total afterthought. Like they don't know that it's something that the organization should really invest in, because in the previous architecture, it wasn't that hard to get right. So it didn't need investment. So you end up with people's development environments and their Docker Compose files not formally maintained by anyone who knows what they're doing. And what I think people should do, and what I've seen some of the more successful companies do, is they have the SRE team, or they have some team that has a lot of DevOps expertise own the development environments. And that doesn't mean that they're kind of mandating from on high, you have to use our blessed kind of development system, but they are providing an option to developers that is well maintained, that works really well. Often it tends to be in the cloud. Often it has a bunch of features that like an individual developer who's just trying to get their job done wouldn't have the time to implement. Like I said, our most recent blog post is on this subject at kelda.io/blog. It was really, really surprisingly polarizing. Like some people were really excited about it. Some people thought I'm an idiot. People have strong opinions about this stuff. But that's the pattern that I've seen has worked well for a lot of people. A couple of kind of tactical things you can do to just improve your Docker Compose files. Unfortunately, like, and you know, the Kubernetes community is really familiar with this. It's like actually pretty hard to get good modularity with YAML. And unfortunately, I think the best way to handle this often is just to like write a script that generates Docker Compose files. I see that really frequently. You typically see that for companies that have hundreds of containers in their development, well, not hundreds, but over 50 containers in their development environment. They'll often have a Python script that generates a Docker Compose file, and maybe it'll have some amount of configuration that will allow you to turn on or turn off various functionality or dependencies to kind of like make it smaller or whatever. Docker Compose has a little known feature called extends that allows you to sort of import chunks of YAML. Unfortunately, it was removed in Docker Compose version 3, but almost no one I run into actually uses Docker Compose version 3. So I still see pretty heavy use of it. And when I write Docker Compose files, I still use 2.7. I don't know how future-proof that is. There's something similar to extend called YAML anchors, called YAML anchors, which is actually built into the YAML spec and allows you to kind of, they're kind of like macros. They allow you to import chunks of YAMLs across multiple across different locations in a file. It doesn't work, to my knowledge, across multiple files. It all has to be within one big file, but that's something you can look at. This is one of these things that an individual developer probably isn't going to mess with, but if you do have an SRE team that's like in charge of this stuff they should look into. And then of course, like use in files, don't commit secrets into your Docker Compose file, like all this stuff. It's kind of table stakes stuff, but I see it all the time. So, okay. Number 4, not devoting sufficient resources to Docker. This isn't a Docker Compose specific thing, but it's a Docker thing. Docker desktop. So I'm assuming most people are running on Mac or Windows. And as I mentioned earlier, Docker runs inside of a virtual machine. Docker desktop uses a large amount of RAM and CPU, particularly when you're developing with more than 2 or 3 containers. And the defaults aren't particularly good. I think what I have displayed here is the default. So it's 2 CPUs and 2 gigabytes of RAM. A lot of our customers have 100 containers. They need 10 or 11 gigabytes of RAM in their development environment. You'll end up swapping without realizing it and just being really slow. So what I typically recommend people do is they actually, and I can actually show you where this is on Mac, but you just go into your Docker preferences. And under resources, I clearly do about 7 gigs and 4 CPUs. You can go even higher than that, but just kind of bump this up. And what I usually do is actually turn Docker desktop. I tend to bump it way high when I'm like actively developing, and then I just turn Docker desktop off when I'm not using it. And that can really, one, speed things up, but also save you time. Often when Docker runs out of memory, it will fail silently. So stuff will just not work and it'll be like hard to tell why. And you can waste a lot of time kind of debugging that. So that's something I recommend people do. The last thing that a lot of people aren't aware of, but Docker tends to leak, particularly disk, but also sometimes memory. It's very easy to end up in a setup where every time you run Docker Compose, you kind of create a volume that's orphaned. There's a command that not a lot of people know about called Docker system prune, which is worth running. And all that does is it shows you all of the kind of like dangling resources that aren't really used anymore: images, volumes, containers, and will prompt you if you want to clean them up. And this is a way that you can save disk space. Again, who knows, it's not profoundly helpful, but it's easy to do. So I typically recommend people do it. Okay, the last one, this one's kind of cheating. It's the obligatory plug for what we're building. So if you aren't interested in the obligatory plug, you can skip this part, but really quick, developing code locally. So the basic argument here, once you've adopted containers, there's this constant pressure to add more and more containers, just because you'll find once you have the infrastructure for creating them, it's easy to solve problems by creating a new container versus kind of refactoring some old code or whatever. Every container you add has RAM and CPU requirements. In production, this is not a problem. You just boot more virtual machines, but on developer laptops, this is a massive issue because your laptop has a finite amount of RAM and CPU. Maybe you're lucky enough to have the latest MacBook Pro with 32 gigs of RAM, but most of us don't. And some of us work at places where our development environments require more than 32 gigabytes of RAM. particularly when you consider that Docker is a virtual machine. It uses a lot of memory just for like the Linux kernel, all that sort of stuff. VS Code is memory hungry. The browser, Slack, Spotify, YouTube, like whatever else you have going on, all takes a lot of resources. So the pattern we've seen is at some point, the number of containers people need for the development environment exceeds the amount of memory on the average developer's laptop. Obviously, there are things that you could do with sufficient effort to kind of slow this process down by like refactoring things, breaking things into smaller pieces, blah, blah, blah. But often it's hard to do this, and we'll see developers whose dev environment requires 10 gigabytes of memory, and they're just painfully slow. Like when I have Docker Compose running, it takes my browser 5 minutes to boot slow. So sorry, the last point I want to make on this, what we found is in a lot of companies, particularly those that adopted cloud native relatively early, they just don't do development on their laptops. They give every developer a virtual machine in the cloud, or they have a dedicated Kubernetes cluster or some sort of dedicated tool that allows developers to run the dependencies that they need to test their code in the cloud where memory is more or less infinite. And the best ones at this, if all of your developers are Kubernetes experts, you just kind of hand them a GKE account and this problem is solved. But because engineers specialize, most places aren't there. So the best ones of this, it tends to be pretty seamless. So where you end up is, the dependencies are running in the cloud, but it's done in such a way where it feels really kind of accessible and simple for developers who aren't DevOps focused and often don't even really fully grok what a container is. So that's why we built Blimp. Blimp is a cloud development environment that's designed to make it really easy to run in your containers in the cloud. And the key kind of differentiating feature of Blimp is that unlike a number of other kind of cloud development solutions, we're drop-in compatible with Docker Compose. So there's literally zero setup work if you're already using Docker Compose. Over time, we're adding additional features that aren't in Docker Compose. That's kind of part of a broader vision that I haven't really talked about in this talk. But to get started, if you're having this performance issue, you can just run in the cloud really easily. And I just wanted to, instead of going over this slide, I just want to do a really quick demo to show what that's like, and then I'll be done. Can people see my terminal? Hopefully. Interpret the silence as yes. So this is a Node.js project. It's got a Docker Compose.yaml file. I actually showed this YAML file in the talk. So it does the kind of volume mounting thing that I showed earlier, skipping the node modules, installing npm install. You could run this Docker Compose file to develop by just doing Docker Compose up like this. With Blimp, instead you just do Blimp up. And it's effectively what it's doing is it's booting the actual container. So instead of running in a virtual machine on my laptop, they're running in a cloud environment, but configured so it's basically indistinguishable from them running on my laptop. So this is taking just a second to boot. So we're kind of creating the environment now, booting the containers. I should do a little dance or something. Okay. Okay, cool. So there it is. It's all running. And the key thing is we didn't have to change the Docker Compose file at all. And the way we work is exactly the same as how we did when working locally. So for example, just like when using Docker Compose locally, you can see your code on localhost. You know, add some to-dos, add some more, and I can edit my code using the host volumes that I showed earlier in the talk, just with kind of whatever editor that I use. I'm personally a VI user. I know everyone's using VS Code these days, but I can edit my code here. It, you know, notice that the code changed and the application changed. So anyway, we think that over time, most development for containers is gonna move to the cloud. Oops, I didn't mean to stop screen sharing. Because of this kind of constant pressure to add more and more resources to the development environment faster than we can add memory or spend engineering effort on shrinking it. And Blimp is a really easy way to kind of get started with that. So those are my mistakes. So that's kind of my talk. Check us out at kelda.io. Feel free to email. I guess the talk's going to be posted, but if you want slides, also feel free to email me at hello@kelda.io. I'm also ethan@kelda.io, so you can email me directly. Follow us on Twitter. And that is my talk. So I'll stop sharing and kind of make myself available for questions or discussion.
Okay, looks like we actually had a comment from Martin. Not so much a question, but feel free to speak up, Martin, if you want.
Sorry, I'm just pulling up. Oh, I agree. My talk was spectacular at Docker.
That was you, huh? So that's twice I have that experience, because you kept using the letters SRE. And
Yeah.
I read this article on Sunday, and I had to look up what's an SRE and figure out how it's different from a DevOps engineer. And then you started saying that, and it was you before, and now it's you again. So
yeah, can I comment on that actually? So I posted an article this weekend that was basically saying, like, what I said, that like someone should own the development environments. And I made like a critical error. I said the DevOps team should own the development environments. And a whole bunch of people who like really believe in the kind of original tenets of the DevOps philosophy got really mad that I said DevOps team, because the whole idea with DevOps is, oh, you don't have a DevOps team. Like the DevOps is like embedded with your development teams. I don't see that happen in practice very often, but like it did piss some people off on Reddit. So I'm switching the terminology I use to SRE, which is less controversial. Yeah.
Okay.
But it just stands for Site Reliability Engineers is all that means. Yeah. Yeah. Mm.
Cool.
Yeah. Mm. What else?
So we have other questions from folks?
if there's no questions, do you have a slide that summarizes all 5 or whatever points?
No, but I do have a blog post that I wrote on this a while back. Let me find it. That it summarizes. Yeah, okay. I just shared a blog post in the chat. If you're watching the recording, I don't know if the chat's in the recording, but it's just kelda.io/blog/common-docker-compose-mistakes. And that kind of goes through all the points with kind of in a little bit more detail. So if you want to kind of refer later, I would recommend checking that out.
After point 2, you asked if anyone had run into these problems. And I definitely run, well, probably both, but definitely the slow volumes.
Yeah.
I've noticed it worse on Windows than on Mac.
Yeah, it's so slow that actually the volumes in Blimp are a lot faster than running Docker Compose locally, believe it or not. And the reason for that is we just don't have strong consistency by default. We use something called SyncThing, which is kind of like, it's like open source Dropbox, basically. It's kind of an encrypted rsync. So we're actually kind of transferring the files over the network at the file layer, not as a sort of full file system. And that's like vastly faster than running Docker locally on Windows often. So yeah, it's one of the, it's one of these kind of perennial problems people have been complaining about a long time. So yeah. Cool. I must say, like, this is my first virtual meetup, and it's been a really good experience. So thanks for inviting me, and it's been great to talk. And obviously, I'm around if there's more questions. So feel free to like ping me privately, or if there's any more questions now, that's great too. Yeah.
Cool. Yeah, I'm glad that you were able to come and present with us. From my perspective, the great thing about being forced into virtual meetups is it's given me access to a whole set of speakers whose plane tickets I would have had to pay for otherwise.
I would have bought my own ticket.
Yeah, or otherwise. I mean, well, one of the things we always ran into was like what would have been our last meetup in February got postponed because on the original date we picked, there were a bunch of conflicts. Somebody was going to fly in, and I called it off because it was like, looks like we're only going to have about 15 people there.
Yeah.
And then you really don't want you to fly to Portland from San Francisco to present to 15 people. And now we don't really have to worry about that. It's sad that we can't have pizza, that we can't socialize in person.
I'll say, I mean, I've done one webinar, and I like the meetup format a lot more because it's just more participatory, and that's really key. If you don't have the participation, then it's almost like, why not just watch a YouTube video, at some point. But
yeah, I keep thinking of adding some games to this. But part of my job at Red Hat is I'm now actually in charge of a whole bunch of our online content.
Yeah.
And as a result, adding extra things I have to prepare for the virtual meetup has just not happened.
Yeah.
Because I can mail stuff to people, so I keep thinking I'm gonna have a quiz at the end, and then whoever wins the quiz gets a piece of swag.
Oh yeah, that would work.
But it requires figuring out what tool will work for the quiz, because the Zoom quiz doesn't quite work for this, etc.
I'll say, if anyone on this talk signs up for Kelda in the next, I don't know, hour, we'll pick one person and we'll send you something, an NES or something. So there, I made up a game.
There we go. All right.
Actually, that's a good question. I think I did sign up for a Kelda account somewhere after DockerCon, but I haven't played with it yet.
Well, if you blimp up, you have to actually blimp up. But if you blimp up, I'll send you something. Or I'll send one person who blimps up. One of those toy, NES things, if you know what I mean. Yeah.
I was kind of, I guess that sounds fun too.
Yeah.
I guess I was wondering if there's it looks like there is a starter.
Yeah, okay. There's a free tier that's actually pretty big. I mean, it's one CPU, 4 gigs of RAM.
Is that new?
We have been really iterating on the pricing. It is new. Yeah, we found individuals just using it. We just want it to be kind of easy to use. We're not really trying to make money off individuals using it. What we found are our real kind of market is these companies with 150 containers, really, really huge things. And that we charge for quite a bit, but
wait, 150 containers in one application?
Yeah. They just, like I said, they just keep adding, and it becomes the war stories around this. I talked to one company that was having a massive fight internally because the new devs were getting 32 gigabyte MacBooks and the old ones only had 16, and the old ones were really mad at the new developers. One company bought every developer a Mac Mini with 64 gigs of RAM. It's one of these problems that people aren't cognizant of until they run into it, and then it's a crisis. So, yeah.
Well, I have wondered about that with some stuff like Quarkus, which is this serverless Java framework.
Oh, that
And you
sounds
do kind of
terrifying.
wonder, with a complicated Java application, how many containers you end up with.
I was totally aware of this Quirkus thing.
Yeah, we'll
Yeah,
probably have it. We'll probably have it on Cloud Native PDX eventually. I haven't scheduled anybody from it yet because I don't think we have a lot of Java developers in the group.
yeah, the Java's so widely used, but the communities are like separate. Like,
Oh, yes.
for some reason.
Well, it's because you have to know so much about Java. Like I always joke, you have to load the entire core class library set into your head before you
Yeah.
can start programming with Java. That once you get into enterprise Java, it becomes hard to do anything else.
Yeah, exactly. And it's interesting how different, like I've noticed like the Kubernetes community like slightly overemphasizes Go. Blimp is written in Go. I love Go. Go is my favorite language to code in, but almost all developers write JavaScript. Like that's what the tools need to be built for. But they're kind of off in their own world, So whatever. It'd be good to kind of like break down silos somehow someday, but that's a bigger problem than I can solve.
Yeah, some people do, but it's a challenge. And
Yeah.
within a project, like within Kubernetes, there used to be components that were written in other things, and they've all gradually been migrated to Go because otherwise what happens is if somebody wants to contribute in a particular area, like if they want to be on the testing team, suddenly you're asking that person to know 4 different programming languages.
Yeah. I also think Go is just the right language for Kube. I think that was a big mistake OpenStack made.
Yeah.
Like, I don't know how you write reliable software in Python. Like, I just like.
I've
without
written
a type checker. I mean, I don't know.
I was gonna say I've written a bunch of stuff in Python. I think on the things that made me abandon OpenStack for Kubernetes, the fact that it was in Python was actually something I was sorry to leave behind.
Okay.
Although the main disadvantage to Python is actually resource consumption, right? As a more abstract language, its resource consumption tends to be fairly high, and there tends to be very little you can do about that. The same is true of Ruby. Same is true of all of the other languages with weak typing, etc.
Really, a lot of this stuff, if you have good governance, you can kind of paper over it. I mean, I think the main reason Kube is doing well is it's governed well.
My main problem with OpenStack, which is something that we decided to be, really super diligent about in Kubernetes because a lot of us worked on OpenStack, was not adhering to the APIs.
Oh.
So OpenStack would publish an API for a component.
Yeah.
But then the other components that actually use that component would bypass the API.
Right. I felt like you had a lot of like vendors who were like, I'm going to like give a bunch of money to the foundation. So now I get to commit stuff and I'm like make an API for my weird vendor specific network hardware thing. And you don't see that in the Kubernetes ecosystem really at all, which I think is why the product is a little healthier. I think you don't see that as bad, at least.
You think it? Well, I mean, you definitely see it on the fringes. We have an awful lot of CNCF projects that are in Sandbox specifically because they are single vendor, right?
Yeah.
But the thing is, they're on the fringes, right? These are not core components. So.
Yeah. Exactly. Yeah.
Anyway, I think it's time to wrap up.
Cool. Thanks, everyone.
So thank you very much for anybody who didn't catch this in chat. The video of this will be up on the CNCF Ambassadors video channel in somewhere to 24 to 48 hours. I'll also put a remark in meetup.com when that video is posted. I would say just subscribe to our playlist. I posted the playlist in chat. Subscribe to our playlist in the CNCF Ambassadors and you'll get notified when the video goes up. And thank you very much, Ethan.
Thank you.
Yeah, thank you.